Let's get the ball rolling. Question number 1. Two fair coins are thrown at the same time, two of them, okay? The random variable x is the number of throws of the coins required to obtain two tails at the same time. Okay, both of them are tails, okay? Find the probability that two tails are obtained for the first time on the seventh row. So you should be clear here that seventh throw of two coins, that means we are throwing two coins at a time, that means 14 throws will be needed. So let's talk about one throw first, only one throw. So in one throw we can get head and head from both the coins, head and tail, or tail and head, or tail and tail. So this is what we are interested in, both tails. So the probability that both are tails is equal to 1/4. You can see there are four options, all equally possible. So 1/4 is the possibility of getting two tails. Now they are asking find the probability that two tails, these two tails, happen for the first time on the seventh throw. That means 6 times when you throw two coins, you fail. So it is geometric distribution. You fail 6 times. So what is the probability of failing? Probability of success of getting two tails is 1/4. We just found out. Probability of failure will be 1 minus 1/4, which is 3/4. So you are failing 6 times. So according to geometric probability distribution, 6 exponent is given to the number of failures. And the 7th time you are successful. You give this one to the success and just multiply this and you will get your answer. Let me use my calculator to find this. 729 over 16, 384. That's what I'm getting here. 729 over 16, 384. Or if you're interested in decimal, it will be 0.044. Okay, let's go to the B part. Find the probability that it takes more than 9 throws to obtain two tails again for the first time. That means it is sure that you're failing for 9 times. Okay, because it's saying more than 9 throws. That means 10th, 11th, 12th, any throw after that you can get success. But for sure you are 100% sure that 9 times you will fail. And after that there is 100% sure that you will get a success after 9 failures. We don't know which attempt, but yes, we are sure after that you will get success. So this is what we will put here. And let me use my calculator to find this also. 3/4 to the power 9 equal to 0.0751 again, right? Let's move on. A summary of 40 values of x, that means n is 40, is given by this information. The sum of all the values after subtracting k from each one of them is 520. That's what it means. This means that you first subtract k from each value, square the value, their sum is 9640. We have to find k. K is a constant, and given that the mean of 40 values is 34. All right, of x, not x minus k. Okay, so let's do this. So mean is 34. So we know that mean is the sum of all the values divided by n. So let's substitute the values. 34 is the mean. Sigma x we don't know, n we know 40. So that makes sigma x equal to 34 multiplied by 40, which will be 1360. All right, but our target is to find k. So let's compare this with sigma x minus k. Sigma x minus k, when it is opened, it becomes sigma x, this one, but this k is multiplied with the number of items we have, number of data. So 40k. That's what it is, right? And sigma x minus k has been given as 520. Sigma x we know now is 1360 minus 40k. This is the equation that will give us the value of k. So let's move 40k to the left side. 40k equal to 1360 minus 520. Yeah, 520k this way. So let's complete it here. 40k equal to 840. So k will be 840 divided by, sorry, 40. 0 cancel, 4 cancel with this one, which is 21. The value of k is 21. Alright. Find the variance of these 40 values. Variance. Okay, so we know that the standard deviation is square root sigma x minus k square over n minus mean square. So mean of this will be sigma x minus k over n and whole square. That's the formula. But they're saying variance, not standard deviation. So we'll square this. That means we'll have to square that one also. Square and square root cancel out. So variance equal to sigma x minus k square over n minus sigma x minus k over n and whole square. And we know all of this. Sigma x minus k square was given as 9640 divided by 40 minus sigma x minus k was given as 520 divided by 40 again, and then whole square. Let's put this all in our calculator and we get 72. That's the variance. Let's go to the next one. For her bedtime, Suki has either chocolate, tea, or milk. Alright. So obviously they have given the probability of each one, so we will write them. Chocolate, tea, milk. Probability of chocolate is 0.45, 0.35, and there was no need to give milk because the sum is always 1. So even if they would have not given, we would add these two and subtract from 1, we would get 0.2. But they've given good. When she has chocolate, the probability that she has a biscuit, so biscuit probability is 0.3. That is not having biscuit is 0.7. And when she has tea, the probability of having a biscuit is 0.6. Okay, biscuit is 0.6 and not biscuit 0.4 obviously. Yeah, 1 minus 0.6 is 0.4. 1 minus 0.3 is 0.7. I hope you are aware that each branch must add up to 1. Alright, next one. When she has milk, she never has a biscuit. Okay, there is a 0% chance that she will have a biscuit. And not biscuit will be 100%. Alright. Find the probability that Suki has tea, given that she does not have biscuit. Probability that she has tea, given that she did not take any biscuit. And according to the formula for conditional probability, it will be Pt intersection n over P of n. So let's focus on probability of not having biscuit. Probability of not having biscuit will be either she had chocolate, 0.45% chance, not percent chance, 0.45 probability, and she did not have biscuit, so 0.7, or she took tea and did not have biscuit, 0.4, or finally she did have milk but not biscuit. So we will just add this up and find our probability of not having biscuit. When I put this whole in my calculator, I will get something. By the time I do this, I request you to subscribe to this channel, hit that notification bell, and like and share this video so that I prepare more and more videos faster than anyone for you. Thank you very much. When I used my calculator, I got 0.655. So we have probability of not having biscuit with us, which is 0.655. What about she had tea and did not have biscuit? And this branch will talk about that fact. Tea and not having biscuit. That means this is the one, 0.35 multiplied by 0.4. And let me put again this in my calculator, and the answer I get is 28 over 131 or 0.214. Okay, move on to question number 4. A fair spinner has edges. Fair spinner, okay? We have to keep in mind. That makes our job easy. Another fair spinner has edges -1, 0, 1. Each spinner is spun, okay? The number on the edges on the spinner comes to rest, okay? Normal, no problem. The random variable x is the sum of the numbers for the spinners, okay? So no twist, just the sum, okay? Draw up the probability distribution of the table. All right. Before we draw probability distribution table, let's draw a table which shows the outcomes. Okay. So the outcomes of the first one are 0, 1, 2, and 2. These two are same numbers, but I'm keeping them different. Why? Because I don't want to make it complex by calculating their probabilities separate. Since it's a fair spinner, it's okay. We can do this. We can write them separate. So there's simplicity in our calculation. Second spinner on the columns now. -1, 0, and 1. Now, from first spinner, if we get 0, in second spinner we get -1, the sum will be -1. And similarly, 0 plus 0, 0 plus 1. 1 minus 1, 1 plus 0, 1 plus 1. 2 minus 1, 2 and 3. 1, 2 and 3. This is the table. These are the 12 outcomes we can have. Okay. So these are the individual outcomes, but they are the real outcomes, total of the two outcomes. Okay. We'll focus on these 12 now. We want to make a probability distribution table for x. So for probability distribution table, we write x and then we write probability of x. So what is the smallest number possible in the outcomes, total outcomes? -1 is the smallest possible, right? What is the greatest? 3. So we'll make a table with -1, then we have a 0, then we have 1, 2, and finally we have 3. Now we'll write the probabilities. It's a fair spinner, all the possibilities are equal, so we can write, just count their total 12. One of them is -1, so the probability of -1 becomes 1 out of 12. Similarly, zeros are 2. So 2 out of 12. I'm not simplifying it because it will be easy to add them now. Ones are 1, 2, 3, 4. There are 4 ones. There are only 3 twos and 2 threes. This is the probability distribution table. If you want to simplify individual one, it's okay. If you don't, it's fine. It's still a table. All right. Now, second one. Find the variance. Okay. So the variance formula is there in your formula booklet also. So don't worry about the formula here. It will be sigma of x square p minus expected value square. All right. So sigma x square p we'll find later. Let's find expected value first. So we know that expected value is sigma xp. Okay. That means every x is multiplied with its probability and added. Let's do that here. -1 multiplied by its probability 1 over 12 plus 0 multiplied by 2 over 12 its probability plus 1 multiplied by 4 over 12 plus 2 multiplied by 3 over 12 plus 3 multiplied by its probability 2 over 12. So let's see how much is that. This will give us minus 1 over 12. This will be 0, gone. 1 times 4 is 4 over 12. Then we have 6 over 12. And then again we have 6 over 12. That will be 6 plus 6, 12 plus 4, 16 minus 1, 15 out of 12. See, it became so easy with same denominator, it became easy to add this up. Let's talk about this sigma x square and multiplied by its p. So what it means, square each x first and then multiply with its probability. So let me do it here. Sigma x square. So x square minus 1 square will be 1 multiplied by its probability, which is 1 out of 12, plus then 0 square is 0 and multiplied by 2, 12 will be 0. So I'm not writing anything, I just write 0 here. 1 square is 1 multiplied by 4 over 12, 4 over 12. 2 square is 4, 4 multiplied by 3 is 12 over 12. And finally, 3 square is 9, 9 times 2 is 18 over 12. And that will be how much? 1 plus 4, 5, 5 plus 12, 17 plus 18, 35 over 12. The sum of all of them will be 35 over 12 minus, and now we know expected value was 15 over 12. Yeah. And that's it. Just put this in a calculator and you get 1.35. That is the variance. Now, next one. Raman and Sanjay are members of a quiz team which has 9 members. Alright. 2 photographs of the quiz team are to be taken. 2 photographs. For the first photograph, 9 members will stand in a line, all 9 of them. How many different arrangements of 9 members are possible in which Raman will be at the center of the line? That means total 9 are there, so 4 will be on his left and 4 will be on his right, and they can stand anyhow. They have 8 places, there are 8 people, 8p8 or 8 factorial is the number of arrangement they can stand on, because Raman will not move, Raman will stay there, Raman is not included, and that comes out to be 40,320. Let's go to the next part of the same question, which is this. How many different arrangements of 9 members are possible in which Raman and Sanjay are not next to each other? Whenever we have such a situation, we remove the ones who do not want to be together. Okay guys, stand up somewhere else. We will look at the rest of the 7. So we'll place them in 7 places. The rest of the 7 people. 1, 2, 3, 4, 5, 6, 7 people. So 7 people will stand in 7 positions. It will be 7p7 or 7 factorial. Right? Now, those 2 guys who do not want to be standing together, ask them to, okay, come, take this, 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 or this. There are so many positions, these dots. Take any of these dot positions so that there is at least one person between them. And that this selection of selecting 2 positions out of 8 will be 8p2. And that becomes our solution, and it ensures that Raman and Sanjay are not together. And we get 282,240 such arrangements. Let's go to next one. For a second photograph, the members will stand in 2 rows with 5 in the back row. Okay, 1, 2, 3, 4, 5, and 4 in front row. Okay. See, in how many different ways can 9 members be divided into a group of 5 and a group of 4? So we'll focus only on the group of 5 first. So there are 9 people, we have to randomly select 5 of them, right? And then 4 are left, we have to select 4 of them. 4C4 is actually 1. You write it or don't, it's okay. So 9C5 is the one that will give you the right answer. And just multiply 4C4, which is 1, it will give you 126 such arrangements. So you might be thinking, why not these 4? If we select this line first, will we get different answer? No, because 9C5 or 9C4 both are equal, both are 126. So it doesn't matter which line you select first. All right. For the random division into 5 groups and group of 4, find the probability that Raman and Sanjay are in the same group as each other. So there are 5 members group here, 4 members group here. It's possible that Raman and Sanjay are here and they are not there, right? That means in this situation we have to select just 3, not 5. Okay, so out of 7 remaining people we have to select 3 and then 4C4 is already there, right? But what if Raman and Sanjay are in this group, right? So in that case, or this will happen, right? Either this will happen or this will happen. In that case, you have to select just 2 of them because our Raman and Sanjay, they have taken 2 places and remaining 2 are to be filled up. So it will be 7C2 first and then 5C5. You will fill up the second row with the remaining people and just do this one. You'll get total number of such arrangements. But the question is about probability, right? Find the probability. So whatever this gives you, just divide it by 126 and you get your answer. 126 was the total number of such arrangements. So let me write 7C2 plus 7C3 here. I will not write this because this is just 1. They are 1, so they don't make any difference. I wrote rest of this. Just put this in a calculator and you get your answer. I'm doing it myself. By the time I do this, please like, share and subscribe to this channel and hit that bell icons to get notifications whenever I upload more IGCSE videos, and I will do it very fast if number of subscribers increase and I'm motivated to make such videos. Thank you. I got 56 of this and 126 was already there. And answer is 4/9. Okay, question number 6. The weights in kilograms of 15 rugby players in Rebels Club and 15 soccer players in Sharks Club are shown here. Okay, they are different clubs. Represent the data by drawing a back-to-back stem and leaf diagram with the Rebels on the left. Okay, so Rebels have to be on the left hand side, so that means the other Sharks will be on the right side. There will be a common column and in this column we will write the tens digit. So smallest number here is 70 something, so 7 will be here, then we have some 80s, then 90s, and then we have 100. Okay, so let's start with Rebels first. Rebels, we write 75. So we just write them randomly but in a sequence. For example, 75 will be here. I'll leave some space for 1, 2, 3, 4 if there are any, right? Then 78 will be more than this. Then we have 79. Then we have 80. For sure 80 will be here. 82. 82 again. 83. 84, and luckily they are in increasing order. 85. What I was expecting was that they will be random. 89, 93, 95, 99, and 102. Similarly, here we will look for the minimum. Minimum here I see 66, and they are also in ascending order. So we'll have to add a 6 on top. And there is no 10. 66, here left one will be smaller and right one will be greater than that. So 71 is the next, 72. In such cases, whenever we make a stem and leaf diagram, we should give a key. Let me write the key here. Key is like this, 2, 8, 3. That means for rebels, it is 82, and for sharks, 83. So that's the back-to-back stem and leaf diagram. Alrighty, let's go to B part. Find the median and IQR of rebels. Okay, for rebels, and we have to focus only on rebels. So let's talk about the median first. Let's write it here. Median. So total there are 15 players, that's what they said. So to we find the median position, we will do 15 plus 1 divided by 2, which is 8. Eighth position is the one where we will find median because it's an odd number, so that's what we do for the odd number. Add 1 and divide by 2. Eighth position. So this is the smallest one, 75, 2, 3, 4, 5, 6, 7, 8. So that means median comes out to be 84. Now, to find IQR, interquartile range, we must know the upper quartile Q3. So upper quartile Q3 is the median of upper numbers above median, the numbers which are more than median. Median is 84. So 1, 2, 3, 4, 5, 6, 7. What is the median of these 7 numbers? That will be Q3. So they are total 7. Again, 7 plus 1 divided by 2. Fourth position will be the Q3. So let's start with the smaller one. This is 85, 86, 89. These are 3. And fourth position is this, which is 93. Lower quartile, which is Q1, will be again the fourth position from back or front of the lower range. So let's start from the front. This is 1, this is 2, this is 3, and this is fourth, right? 75, 78, 79, and 80. 80 is the lower quartile. And interquartile range is Q3 minus Q1. That becomes 93 minus 80. 13 kg is the interquartile range. Okay, let's go to C part. The box and whisker plot for the sharks is drawn. Okay. On the same diagram, draw a box and whisker plot for rebels. So for rebels, first we should know what is the smallest value. The smallest value we saw was 75. What is the greatest value? Was 102 as far as I remember. 102. Yeah. So Q1 we just found out 80. Median was 84 and Q3 upper quartile was 93. So we have these 5 numbers. We will put them one by one below sharks. Let's write rebels here. So 75 first. 75 is here, a dot. Greatest value is 102. So 102 will be here. Next, Q1 is 80. Then median is 84. Alright, and Q3 is 93. 1, 2, 3, 93. So we'll keep smallest and greatest value as they are, but for the ones which are others, we'll draw vertical lines on them. So let's see, what is the width of this one given? 2 units. So let's draw 2 units. This is vertical line, and vertical line. Join these vertical lines with horizontal lines, right? And the greatest and the smallest are drawn from the middle, just like they have drawn in the above box and whisker. So we will just put a vertical line small here and small here. This becomes box and whisker diagram for rebels, and that's what we've done. Make one comparison between the weights of players and rebels club. Okay, so these players of shark and rebels, we can see that the box, on average, the box central tendency of the box of rebels is on the righter side, higher side. So we can say one sentence. Do you want to say one sentence, right? So the average weight of rebels is higher than sharks. The times in minutes that Carly spends each day on social media are normally distributed with mean 125 and standard deviation 24. On how many days of the year, 365 days, would you expect? So they are asking expected number of days Carly to spend more than 142 minutes on social media. So let's draw the situation first. This is normal distribution curve. Mean is 125 minutes. Standard deviation is 124, they've given here. So we have to find, she spends more than 142 minutes. So obviously it will be more than 125. So they want to find this area, right? But using our normal distribution table, we can find only the area less than 142. So we will do that. We'll find less, find the probability of this one, and we'll just subtract from 1. We'll get this area, right? Let's do that. Let's find the z-score for x is less than 142. It will be 142, that's value itself, minus mean, which is 125, divided by this, which is 0.708. And now we need a probability for x to be less than 142, this dotted part. And for that we need to look at the table. Let's go and find from the table 0.708. 0.7 is here, 0.7580, 0.7580, and then we have 8 is 24. So we add them, 0.7604. That is the probability that number of minutes used per day are less than 142. 0.7. But our question was to find this area. So probability that x is greater than 142 will be 1 minus 0.7604. But the actual question was, on how many days do you expect out of 365 days that she will use the social media for more than 142 minutes a day? So we know the probability now. We'll just multiply it by 365 days. So 1 minus 0.7604 multiplied by 365, that will be the expected number of days. And my calculator gives it 87.45. So 87 days we can do. We can't write 87.45, 87. So 87 days. These many days are expected. Alrighty, let's move on to the next one, which is this. Find the probability that Carly spends more than 142 minutes on social media on fewer than 2 of the 10 randomly chosen days. That means now our chosen days are very less and fixed. And that reminds us of binomial distribution. So we'll use binomial distribution because there are 4 conditions for binomial distribution. All 4 should be met. Is the probability of spending more than 142 minutes same for all days? Yes, it is. 1 minus 0.7604, that's what we did. Let's give it a number. It will be 0.2394. Okay, this is fixed for every day. So that's correct. Done. Are number of selections definite? Yes, they are 10. The third condition, is every day independent from the previous day? Yes, it is. Third condition is also met. And fourth, is there a success and a failure? Yes, success is if she uses more than 142 minutes is success, 142 or less is a failure. So all 4 conditions are met, we can use binomial distribution. And 2 out of them, they're saying fewer than 2. Fewer than 2 means probability of fewer than 2 is same as probability of 0 or probability of 1. We can interpret them like this. These two are fewer than 2. And for this, we use binomial distribution 10C0. The success is 0.2394. We want 0 days, but all 10 days we want failure, which was 0.7604. Or this probability of 1 will be 10C1 02.2394 to the power 1, 0.7604 to the power 9. And I got an answer of 0.268. Let's move on to the next part. It's still there. Okay. On 90% of days, Carly spends more than T minutes. So let's visualize this again. This is the graph. More than T minutes. That means T will be somewhere here. That's how it can be 90% more than this. So that means this is a very small number. T is very small number as compared to the mean of 125 minutes. Find the value of T. So we know that T will give us a negative Z score. So let's turn it into a positive Z score first by writing here. Let's call it T prime. Okay. This is the one whose probability less than this T prime will be 90% because it is more than T 90%. Here it will be less than T prime 90%. And that's what we want. So probability of X is less than T prime is 90%. We know this. Let's compare this with Z scores and find corresponding Z score for this one. So 0.9 will be here, 0.9032, so 0.888997 here. This is the one, which is 1.28, 1.28, but it is 997, so I know 3 more. There is no 3, we have just 4 and 2. So let's take 1.5, okay? So we can write 1.2815. This will be the Z score, to be precise. So let's use this Z score to find the T now, T prime rather. So let's continue. Z score for X less than T prime was 1.2815. But T prime was not our target was T. So Z X less than T, this is what we have to do, and for that we just have to convert this into negative Z score. That's it, because they are equally distant from the mean, so just add negative to it. And now we know Z score formula is X minus mean divided by standard deviation equal to Z score. And X in this case we don't know, it is T, but we know mean 125, we know standard deviation which was 24, and Z score we know now minus 1.2815. So T minus 125 equal to minus 1.2815 times 24. 4. So let's complete it here. T minus 125 equal to minus 30.76. And now we will isolate T, which will be 125 minus 30.76, and that will be 94.24, and we can say that 94 days.